We are living through the dawn of a new age, and at its heart is a technology so powerful, so strange, and so full of promise and peril that it forces us to reconsider the very nature of reality itself. Today, we're not just talking about computers. We're talking about a new kind of consciousness being born in labs of silicon and superconductors. We're talking about the quantum age. And the most important question is, what role will you play in it? Let's begin not with a theory, but with a fact, a world-changing event that has already happened. In a heavily shielded, cryogenically frozen chamber, a machine performed a calculation that redefined our understanding of what is possible. Google's Willow quantum chip was given a specific esoteric problem to solve. It completed the task in just under 5 minutes. Now, how long would that same problem take our most powerful classical supercomputer, the kind that fills entire buildings and consumes enough energy to power a small town? The staggering answer is an estimated 10 septillion years. Let's try to wrap our heads around that number. 10 septillion is a 1 followed by 25 zeros. The universe itself is only about 13.8 billion years old. So this machine accomplished in the time it takes to brew a cup of coffee what our best current technology couldn't finish if it had started at the Big Bang and continued for 1 trillion lifetimes of the universe. This isn't just an improvement. This isn't a faster chip. The event was hailed as a demonstration of quantum supremacy. The moment a quantum device solves a problem that is practically impossible for any classical computer. This wasn't Google's first time crossing this threshold. Their earlier Sycamore chip did something similar back in 2019, performing a 10,000-year calculation in just 200 seconds. But the Willow chip's achievement is on another scale entirely, silencing many of the debates and proving that the quantum revolution is not a distant promise. It is a present-day reality, and its arrival presents us all of humanity with a profound choice. The blueprints for the next era of civilization are being drawn right now. The question that hangs in the air, silent but urgent, is this: who will be the architects? For many, the term quantum conjures images of bizarre, abstract physics, something confined to chalkboards and theoretical papers. But that perception is already outdated. This isn't just about performing strange calculations with no real-world application. Quantum solutions are already being deployed, delivering tangible, game-changing results for businesses today. Think about the logistical nightmare of a major shipping company. It's a classic optimization problem, and for one company, this weekly planning process was a 25-hour ordeal. Using quantum-inspired optimization algorithms, they slashed that time to just 2 minutes. This isn't merely an efficiency gain. It's a transformation in operational agility. In the world of advanced manufacturing, a firm was struggling with production waste, a complex issue tied to material flows and machine scheduling. By applying quantum principles to their factory floor logistics, they cut that waste by an incredible 80%. Imagine the economic and environmental impact of that single change scaled across an entire industry. And consider the pressing challenge of climate change. One organization, focused on reducing its carbon footprint, used quantum modeling to optimize its energy consumption and supply chain. The result? A 57% reduction in emissions. These aren't isolated anecdotes. From accelerating drug discovery by modeling molecular interactions in ways classical computers never could, to revolutionizing financial modeling by navigating near-infinite variables to find optimal investment strategies, quantum computing is actively solving previously unsolvable problems. 7. It is making the impossible possible, not in 2040, but right now. With this immense power comes an equally immense vulnerability. The story of quantum computing is a story of a paradox a double-edged sword that could simultaneously be our greatest protector and our most formidable threat. The very properties that make a quantum computer so brilliant at solving optimization problems, its ability to hold multiple possibilities at once in a state of superposition and connect them through entanglement, also make it the ultimate codebreaker. Our entire digital world is built on a foundation of encryption. Every password you use, every credit card transaction you make, every secure message you send is protected by mathematical problems that are too hard for classical computers to solve in a reasonable time frame. The most common of these is RSA encryption, which relies on the difficulty of factoring massive numbers into their prime components. For a classical computer, this is like trying to find two specific grains of sand on all the beaches of the world. But for a powerful quantum computer running an algorithm called Shor's algorithm, it's a trivial task. The moment a sufficiently powerful quantum computer goes online, it will have the potential to shatter the locks on our digital vaults. It could render our entire global financial system, our military communications, and our personal data utterly transparent. Experts predict this Q-day could be just a few years away, and the threat is so significant that intelligence agencies are already engaging in what's called harvest now, decrypt later. They are vacuuming up vast amounts of encrypted data today, knowing that they will be able to unlock it all once a quantum key is forged. Yet, here is the beautiful and urgent twist in the narrative. The problem contains its own solution. The same quantum mechanics that threatens our security also offers the path to a new, theoretically unbreakable form of it. This is the world of quantum cryptography and quantum key distribution, QKD. Using the principles of quantum physics, we can create communication channels where the very act of a third party trying to observe the data instantly changes it, alerting the users that they are being watched. It's like having a secret message that vaporizes the moment an unauthorized person looks at it. This isn't just better encryption. It's a new paradigm of secure communication, guaranteed not by complex math, but by the fundamental laws of the universe. The race is on, not just to build quantum computers, but to rebuild our entire digital infrastructure before the old one becomes obsolete. The immense strategic implications of this technology have not been lost on the world's governments. What we are witnessing is a new kind of global race, a high-stakes competition for quantum sovereignty. This isn't about territory or resources in the traditional sense. It's about controlling the computational high ground of the 21st century. Nations are pouring billions into coordinated national strategies, understanding that the country that leads in quantum will have a decisive economic, scientific, and military advantage for decades to come. Australia has committed over $620 million to build a utility-scale, error-corrected quantum computer. Japan has announced a staggering $7.4 billion national commitment to quantum technology, aiming to integrate it across its economy. The United States and China are locked in their own fierce competition, with massive investments flowing from both public and private sectors. The European Union is funding continent-wide initiatives to build a quantum internet and secure communication networks. This is a geopolitical chess game where the pieces are qubits and the board is the future of global power. However, as this race accelerates, a critical bottleneck has emerged. It's not a lack of funding. It's not a shortage of technological ambition. The most significant barrier to progress is a severe global shortage of human talent. We desperately need a new generation of scientists, engineers, and technicians who possess the unique, interdisciplinary skills required to build and operate this technology. This isn't just about being a physicist or a computer scientist. It's about a deep fluency in both, combined with knowledge of materials science, electrical engineering, and complex software development. The global talent pool is tiny compared to the demand, and the competition to attract and retain these quantum natives is just as fierce as the race to build the machines themselves. Which nation or company can cultivate this talent fastest may ultimately determine the winner of the quantum race. Now, Let's take a step back from the geopolitics and the technology and venture into a more philosophical and perhaps more personal domain. There is a curious and profound parallel being drawn between the inner workings of a quantum computer and the processes of our own human consciousness. It's a metaphor, to be clear, but a powerful one that can help us grasp the strange nature of this new reality. A classical computer works with bits-definite states of 0 or 1. It is a world of absolute certainty. A quantum computer, however, operates on qubits, which exist in a state of superposition. A qubit can be a 0, a 1, or crucially, a blend of both simultaneously. It exists not as a fixed answer, but as a cloud of probabilities, a realm of pure potential. It holds all possible answers at the same time until the moment of measurement, when this cloud of possibility collapses into a single definite reality. Doesn't that sound oddly familiar? Think about the nature of your own mind. Before you make a decision, your consciousness holds multiple, often contradictory, thoughts and possibilities at once. You weigh different futures. You feel conflicting emotions. You exist in a superposition of potential actions. You might think, I will take that job, and simultaneously, I will stay where I am. Both realities exist as potentials within your mind. Then, the moment of decision arrives. You choose. And in that instant, the wave of possibility collapses into the single chosen reality of your experience. This parallel invites us to see quantum computing not as something alien and mechanical, but as a reflection of a process that is deeply, fundamentally human. It suggests that both systems, the quantum computer and the conscious mind, are powerful because they navigate the world not through rigid certainties, but by embracing the vast, shimmering landscape of uncertainty and possibility. What if we are, in our own way, quantum systems? One of the most immediate and revolutionary applications of this new form of computation lies in the world of material science. For centuries, our discovery of new materials has been a slow, painstaking process of trial and error, guided by intuition and accidental discovery. But what if we could design new materials from the ground up, atom by atom, with precisely the properties we desire? This is the promise of quantum simulation. The interactions between atoms and molecules are governed by the complex laws of quantum mechanics, laws that are fiendishly difficult for classical computers to model with any accuracy. Even our best supercomputers have to use approximations and shortcuts. But a quantum computer speaks the universe's native language. It can simulate these molecular interactions with perfect precision because it operates on the same principles. This capability is poised to unlock a new golden age of material science. Imagine designing a substance that is lighter than aluminum, but stronger than diamond, revolutionizing everything from aerospace to construction. Picture creating new types of catalysts that can efficiently and cheaply capture carbon directly from the atmosphere, offering a powerful tool in the fight against climate change. Or what about room temperature superconductors that could enable lossless energy transmission, completely transforming our power grids? These are not science fiction fantasies. They are the tangible goals that scientists are now pursuing with the power of quantum simulation. By allowing us to understand and manipulate matter at its most fundamental level, quantum computers are giving us the ability to design the very fabric of our future world, one atom at a time. Nowhere is the potential impact of this technology more profound or more personal than in the realm of medicine and human health. The human body is a biological machine of staggering complexity, and at its core, it is a quantum system. The intricate dance of proteins, enzymes, and DNA is governed by the same quantum rules that power a qubit. Consider the fight against diseases like Alzheimer's. A key challenge is understanding how potential drug molecules will interact with specific proteins in the brain. There are countless possible configurations, and modeling these interactions with perfect accuracy is beyond the scope of classical computers. But quantum computers can model this protein folding problem with unprecedented fidelity. allowing researchers to design drugs that are far more effective and have fewer side effects. This could dramatically accelerate the pipeline for new treatments, cutting down the time and cost from discovery to clinic. Beyond drug discovery, we are on the cusp of a new era of personalized medicine. By simulating how different treatments will interact with an individual's unique genetic profile, doctors could one day prescribe therapies tailored not just to a disease, but to the specific patient. And the revolution doesn't stop with treatment. Quantum sensors, which leverage the extreme sensitivity of quantum states to their environment, are being developed for diagnostics. Imagine a device that could detect the chemical markers of cancer from a single breath sample, allowing for diagnosis at the earliest, most treatable stages. Or sensors that could map brain activity with such precision that we could unlock new insights into neurological disorders like Parkinson's or epilepsy. The quantum age of medicine promises not just to treat our illnesses, but to fundamentally deepen our understanding of human health itself. When a technology emerges that can solve problems fundamentally inaccessible to its predecessors, it doesn't just create new products, it creates a new economy. We are witnessing the birth of the quantum economy, a transformation that experts believe will be as significant as the digital revolution. Projections from firms like McKinsey suggest that quantum computing will create between $450 billion and $850 billion of economic value by the year 2040. This value won't come from simply doing things faster. It will come from achieving what is now known as quantum advantage, the ability to solve problems that competitors, relying on classical computers, cannot even attempt. In finance, quantum algorithms will move beyond simple risk assessment to optimize global investment portfolios with millions of variables in real time, potentially creating market efficiencies we can't yet imagine. In logistics, it's not just about finding a faster delivery route. It's about optimizing an entire national supply chain simultaneously, responding instantly to disruptions and creating a level of resilience and efficiency that is simply impossible today. In transportation, quantum systems will manage the flow of autonomous vehicle fleets in complex urban environments, optimizing traffic and energy consumption on a citywide scale. In this emerging economy, the most valuable skill will no longer be just coding or data analysis. It will be quantum literacy, the ability to understand the principles of quantum computing and identify the problems that are best suited for this new paradigm. Companies that cultivate this literacy will gain a decisive competitive edge. They won't just be outperforming their rivals. They will be operating in a completely different league, solving a class of problems that are invisible to the rest of the market. The quantum economy will reward not just speed, but a new kind of insight. With every great technological leap, there is a corresponding societal challenge. The speed of quantum development is breathtaking, but our social, political, and legal institutions are struggling to keep up. This has created a dangerous governance gap, a chasm between the power of the technology and our collective ability to manage it wisely. Crucial decisions that will shape the quantum future for everyone are being made right now, often behind closed doors. Small groups of technical experts and policymakers are debating and setting the standards for quantum-safe encryption. Think about that. The very foundation of our future digital security is being architected before the public has even had a chance to understand the stakes. Similarly, as quantum computing begins to converge with artificial intelligence, profound ethical questions arise. What are the moral implications of a quantum-enhanced AI that can solve problems and make decisions in ways that are completely opaque to human understanding? How do we ensure that this immense computational power is used for the benefit of all, rather than exacerbating existing inequalities? Our democratic processes, which are designed for slow, deliberate debate, are ill-equipped to handle the exponential pace of quantum development. By the time a regulatory framework is proposed and debated, the technology it's meant to govern may have already leaped generations ahead. This governance gap represents a critical race against time. We must find new, more agile ways to have a broad, inclusive public conversation about the ethics and governance of the quantum age. We need to bridge the gap between the experts who are building this future and the public who will live in it, ensuring that this powerful new chapter in human history is written by all of us for all of us. As we look further into the quantum future, we can begin to see the outlines of a new kind of global infrastructure, one built not on classical bits and wires, but on the fundamental principles of quantum mechanics. This will be an invisible layer of technology that underpins our world, making it more secure, more precise, and more intelligent. At the heart of this vision is the quantum internet. This won't be a faster internet in the way we typically think of speed. Its revolutionary feature will be its security. By transmitting information encoded in the quantum states of entangled particles, we can create communication networks that are inherently unhackable. As we discussed, any attempt to eavesdrop would disturb the system and be instantly detected. This would create a new gold standard for secure communication, essential for everything from financial transactions to national security. Field tests in early networks are already being built in places like Chicago and across countries in Asia and Europe, laying the groundwork for this global infrastructure. Alongside the quantum internet, we will see a proliferation of advanced quantum sensors. These devices can measure tiny fluctuations in gravity, magnetic fields, and time with astonishing precision. This opens up a world of possibilities. Imagine navigation systems for ships, submarines, or aircraft that work perfectly deep underground or underwater, completely independent of GPS. Picture sensors embedded into the structure of a bridge or a skyscraper, monitoring its structural integrity in real time by detecting microscopic changes in stress and strain. Envision a national energy grid that is optimized moment by moment by a network of quantum sensors, balancing supply and demand with perfect efficiency and preventing blackouts before they can even begin. This is the promise of the quantum infrastructure, a world that is safer, more resilient, and more deeply connected to the subtle forces that govern our reality. Perhaps the most powerful aspect of the quantum revolution is that it is not happening in a vacuum. It is part of a great convergence, an unprecedented cross-pollination of multiple transformative technologies, each one amplifying the others. Quantum computing is converging with artificial intelligence, biotechnology, and nanotechnology, creating a powerful innovation feedback loop that is compressing the timeline from discovery to application at a dizzying pace. Consider the relationship between quantum computing and AI. While AI excels at finding patterns in vast datasets, quantum computing is brilliant at solving the complex optimization problems that are often at the heart of AI challenges. A quantum computer could supercharge machine learning, allowing AI models to be trained more efficiently and to tackle problems of far greater complexity. In return, AI is being used today to help design better quantum hardware and control systems, accelerating the development of the quantum computers themselves. Now, add biotechnology to the mix. As we've seen, quantum computers can simulate molecules to design new drugs and therapies. When combined with AI, it can identify potential drug candidates from massive biological datasets, and nanotechnology that can deliver these drugs to specific cells in the body. We have a complete end-to-end revolution in medicine. This convergence creates a self-reinforcing cycle. A breakthrough in quantum computing accelerates AI. That smarter AI leads to new discoveries in biotech. Those discoveries create a need for new quantum simulations, driving further advances in quantum hardware. This feedback loop means that progress is no longer linear. It's exponential. We are not just on a single path of innovation. We are at the center of a rapidly expanding web of interconnected breakthroughs, each one pushing the others forward faster than we could have ever imagined. For all this talk of futuristic laboratories and global infrastructure, it's easy to see quantum mechanics as something distant, cold, and separate from our lived experience. But the most profound truth is that quantum effects are not just out there, they are in here. You, yourself, are a quantum system. The quantum world isn't a strange alien realm. It is the fundamental operating system of our biological reality. The very oxygen you are breathing at this moment is a product of photosynthesis, a process in which plants capture the energy of sunlight with near-perfect efficiency, thanks to a quantum phenomenon called superposition. The chlorophyll molecule essentially explores all possible energy pathways at once to find the most efficient one. Within your own body, enzymes, the biological catalysts that make life possible, rely on a quantum effect called tunneling to speed up chemical reactions. They allow particles to pass through energy barriers that, according to classical physics, they shouldn't be able to cross. This is how you digest your food and power your cells. Even your sense of smell may be a quantum process, with receptors in your nose potentially identifying molecules by the quantum vibrational frequencies of their atomic bonds. From this perspective, the development of quantum technology is not humanity creating something unnatural. It is humanity finally learning to build tools that work in harmony with the principles that have governed life for billions of years. We are not inventing a new reality. We are simply becoming more conscious and more capable participants in the quantum nature of our own existence. This reframes the entire journey. It's not just an exploration of technology, but a deeper exploration of ourselves. In our classical digital world, we have come to equate computational power with certainty. We expect our computers to give us a single, definitive, correct answer. But here we encounter one of the most beautiful and counterintuitive truths of the quantum age, the wisdom paradox. As our quantum computers become infinitely more powerful, they will not eliminate mystery. They will deepen it. A quantum computer does not operate on the logic of absolute certainty. It operates on the language of probability. Its power comes from its ability to hold the entire spectrum of possibilities in a delicate balance. It reveals a universe that is not a deterministic machine, but a fundamentally uncertain and probabilistic dance. The final answer it gives is simply the most likely outcome from a vast sea of potential realities. This presents a profound challenge to our way of thinking. We are used to seeking clear, black and white answers. But the quantum world teaches us that reality is painted in infinite shades of gray. This paradox suggests that as our raw computational power grows to unimaginable levels, the most valuable and uniquely human skills will not be calculation or data processing. The future will belong to those who can look at a cloud of quantum probabilities and ask the right questions. It will belong to those who can take a computational result that is merely highly probable and combine it with ethical insight, creative intuition, and a deep understanding of human context. In the quantum age, the more our machines know, the more we will be called upon, not just to be smart, but to be wise. Given the high-stakes geopolitical race we described earlier, it's easy to frame the quantum revolution as a competition, a finite game with clear winners and losers. But there is a deeper, more hopeful way to see this moment. Inspired by the work of the philosopher James Carse, Carse distinguished between finite games, which are played for the purpose of winning, and infinite games, which are played for the purpose of continuing the play. A finite game has fixed rules, a clear boundary, and a defined end. A game of chess is a finite game. A war is a finite game. The goal is to defeat the opponent. An infinite game, however, is played to keep the game going, to bring more players into the game, and to explore the endless possibilities of the game itself. Science is an infinite game. Art is an infinite game. The goal is not to win, but to perpetuate the play. Quantum computing can be framed as the ultimate infinite game. It is not a tool for finding the final answer to reality. It is a tool for asking deeper and more beautiful questions. It is a portal into the fundamental patterns of the universe, an exploration with no foreseeable end. This reframing has profound implications. It suggests that while nations may compete in the short term, The ultimate purpose of this technology is not for one group to dominate another. It is a species-level invitation to a collaborative exploration of reality's deepest layers. The true goal is not to achieve quantum supremacy, but to participate in a quantum collaboration, an infinite game where the prize is not victory, but continued discovery, shared understanding, and the joy of inviting everyone to play. Let's return to that intimate parallel between quantum states and our own inner world. This connection is perhaps nowhere more evident than in the mysterious process of human creativity. Where does a new idea come from? How does a moment of insight, an aha moment, emerge? It rarely comes from a linear, logical progression. Instead, it often arises from a state of mind that feels very much like a quantum superposition. The creative mind holds multiple disconnected ideas, fragments of memory, and unresolved questions in a kind of mental cloud. These elements exist in a state of flux, of pure potential, without a clear connection or a final form. The artist, the scientist, the entrepreneur, they all learn to sit comfortably in this cloud of uncertainty, this space of not knowing. Then, suddenly and often unexpectedly, a connection is made. The disparate elements collapse into a coherent new pattern. A solution emerges. The poem writes itself. The scientific theory crystallizes. This is the moment of creative insight, the collapse of a wave of possibilities into a single, elegant reality. From this perspective, human consciousness, especially in its creative and contemplative modes, is a kind of quantum computer. It is a system that holds multiple layers of meaning, memory, and possibility simultaneously. It navigates the world not by processing a linear stream of data, but by allowing new realities to emerge from a superposition of awareness. This metaphor doesn't just help us understand quantum computers. It gives us a new and powerful language for understanding the deepest and most mysterious aspects of our own minds. The impact of a technological revolution isn't always loud and dramatic. Often, its deepest influence is felt in subtle, almost invisible ways, as its core principles begin to reshape our thinking and our tools long before the technology itself becomes mainstream. This is already happening with quantum computing. The invisible ripples of this new reality are already here. Even when running on our classical digital computers, algorithms inspired by quantum principles are beginning to change our world. These quantum-inspired algorithms mimic the logic of quantum mechanics, exploring many possible solutions at once, solve complex optimization problems more efficiently than traditional methods. They are being used to optimize financial markets, finding more stable and profitable investment strategies. They are helping to increase agricultural yields by determining the most efficient use of water and fertilizer across vast farmlands. They are reshaping the flow of traffic in our cities, creating adaptive systems that respond to congestion in real time. These systems are making our world more efficient, more responsive, and more resilient. And they are doing so quietly, behind the scenes. This is the subtle vanguard of the quantum revolution. It's not about the hardware in a lab. It's about a new way of thinking, a new approach to problem solving that is inspired by the universe's own computational logic. Long before most of us ever log on to a true quantum computer, our lives will have already been reshaped by the elegant and powerful ideas it represents. Every great scientific revolution gives humanity a new set of metaphors to understand the world and our place in it. The Newtonian revolution gave us the metaphor of the clockwork universe, a deterministic machine governed by predictable laws. The digital revolution gave us the language of information, processing, and networks. Now, the quantum revolution is infusing our culture with a new, more nuanced, and perhaps more accurate set of concepts for understanding our complex reality. Think of the word complementarity, a core principle of quantum mechanics which states that an object can have properties that are seemingly contradictory but are both necessary to describe it, like a particle and a wave. This concept is providing us with a powerful way to move beyond black and white, either or thinking. It allows us to hold multiple, seemingly contradictory truths at the same time, to understand that two opposing political viewpoints might both contain a piece of the truth, or that a person can be both strong and vulnerable simultaneously. Consider entanglement, the idea of a deep and instantaneous interconnectedness between particles, no matter how far apart they are. This is becoming a potent metaphor for understanding our own deep interdependence. It reminds us that we are not isolated individuals, but part of a deeply connected social and ecological fabric, where an action in one part of the system can have instantaneous effects on another. These quantum metaphors are subtly changing the fabric of our cultural conversation. They are giving us a new language to describe the ambiguity, interconnectedness, and complexity of our world, allowing us to think in ways that are less rigid, more holistic, and ultimately more in tune with the nature of reality itself. As quantum concepts seep into our culture, they are also opening up entirely new frontiers for creative expression. Artists, musicians, and writers are beginning to use the principles of quantum mechanics not just as a subject, but as a new medium, a new set of tools for creating art that challenges our very notions of reality and observation. We are seeing the emergence of visual art created with true quantum randomness, generated by the unpredictable decay of a single atom. The resulting patterns are not pseudo-random, like those from a classical computer, but are born from the universe's fundamental uncertainty, creating works of art that are truly unique and unrepeatable. Musicians are composing pieces that exist as a probability cloud of notes and rhythms. The written score doesn't define a single performance, but a field of potential musical realities. The final piece is only realized in the moment of performance, when the choices of the musician, the observer, collapse the probability cloud into a unique, fleeting experience. No two performances will ever be the same. Writers and game designers are creating narratives that exist in a superposition of multiple storylines. The plot is not a fixed path, but a branching tree of possibilities. The choices made by the reader or player act as a measurement, collapsing the story into their own unique reality. Your experience of the story will be different from mine, because our observations created different worlds. This is art in the age of quantum possibility. It is an art that is participatory, uncertain, and deeply intertwined with the role of the observer. It doesn't just depict reality, it invites us to co-create it. A tool this powerful does not come with a built-in moral compass. The quantum age forces us to confront some of the most difficult ethical questions humanity has ever faced, and it demands a new kind of ethical reasoning, one that can operate effectively under conditions of deep and fundamental uncertainty. First, there is the challenge of access. How do we ensure that the immense power of quantum computing benefits all of humanity, rather than becoming a tool that widens the gap between the haves and the have-nots? If quantum advantage becomes the key to economic and scientific progress, how do we prevent the creation of a permanent quantum divide? Then, there is the urgent challenge of managing the global transition to quantum-safe security. We know that Q-Day is coming, the day our current encryption becomes obsolete. How do we orchestrate a coordinated, global upgrade of our entire digital infrastructure in a way that is fair, orderly, and doesn't leave vulnerable populations or smaller nations behind? And perhaps most profoundly, we must consider the moral status of quantum-enhanced artificial intelligence. If we create an AI that can solve problems far beyond human comprehension, an AI whose inner workings are a black box of quantum probabilities, what are our responsibilities to it? And what are its responsibilities to us? How do we build ethical guardrails for a form of intelligence that we may not be able to fully understand? These are not questions for a distant future. They are questions for right now. Navigating these moral frontiers requires more than just technical expertise. It requires a global conversation, a deep commitment to foresight, and a new kind of ethical framework that embraces humility in the face of profound uncertainty. It can be easy to feel like a passive observer to a future It is being built by a handful of scientists and corporations in far-off labs. But the central message of the quantum age is that the observer is never passive. The act of observation shapes reality, and the quantum decision is not a single event that has already happened or will happen in the future. It is a continuous participatory process that is happening right now, and you are a part of it. The future of the quantum age is not a predetermined outcome. It exists today as a superposition of all possible futures of unprecedented progress and equity, and futures of division and peril. Our collective choices, our collective awareness, are the measurement that will collapse this cloud of possibilities into a single manifest reality. Every choice to learn about this technology, to engage in a conversation about its implications, to consider its ethical dimensions, is an act of shaping that future. Every student who decides to study physics, every citizen who asks their representatives about national quantum policy, every business leader who considers the societal impact of their quantum strategy, all are contributing to the collective wisdom that is guiding this transformation. You are not just a spectator. You are a participant. The future is not something that happens to you. It is something that happens through you. The continuous choice is yours. It is ours to make. What kind of quantum future will we choose to create together? At the farthest frontiers of modern science, we often find ourselves circling back to the deepest insights of ancient wisdom. There is a surprising and beautiful parallel being drawn between the strange world of quantum physics and the insights of ancient contemplative traditions like meditation. It seems that our external exploration of the universe and our internal exploration of consciousness are leading us to the same fundamental truths. Quantum physics tells us that the observer is not separate from the observed. The act of measurement fundamentally influences the reality being measured. For thousands of years, contemplative traditions have taught that our state of mind, our awareness, is not a passive mirror of the world, but actively shapes our experience of reality. The world we perceive is a reflection of our own consciousness. Quantum mechanics describes a ground state of pure potential, a vacuum that is not empty, but is teeming with all possibilities, from which all manifest phenomena emerge. Similarly, many contemplative traditions speak of a fundamental ground of being, a space of pure, silent awareness or emptiness, from which all thoughts, feelings, and experiences arise. Both domains, the scientific and the contemplative, involve a skillful and patient relationship with uncertainty. They both appreciate that at the deepest level, reality is not made of solid, separate things, but of interconnectedness, probability, and potential. This convergence suggests that the quantum revolution may be more than just a technological one. It may be part of a deeper shift in human consciousness, a new integration of our objective, scientific understanding of the world with our subjective, contemplative experience of it. Venturing into more speculative, but deeply intriguing territory, some thinkers are beginning to use quantum concepts as powerful metaphors for understanding collective consciousness and social dynamics. While it's crucial to state that this is not yet scientifically proven, the metaphor itself is a powerful tool for thought. Could the quantum concept of non-locality, the idea that entangled particles remain connected and influence each other instantaneously, regardless of the distance separating them, offer a new way to think about the deep, often unseen connections between human minds? We've all had the experience of thinking of someone just moments before they call, or feeling the mood of a room the instant we walk into it. Could these be subtle expressions of a collective field of consciousness? This perspective frames individual contemplative practice, like meditation, in a new light. It's not just a tool for personal well-being or individual development. If we are all part of an interconnected field, then an individual who cultivates a state of coherence, peace, and wisdom within themselves may not just be changing their own mind. They may be contributing a resonant signal of coherence to the entire collective field, subtly influencing the whole. Again, this is a metaphor, a philosophical exploration, but it's a compelling one. It invites us to consider that our individual inner work might have a collective outer impact, and that cultivating our own consciousness could be one of the most powerful ways to contribute to a more coherent and compassionate world. As we draw these parallels between quantum systems and conscious experience, we must approach one of the greatest unsolved mysteries in all of science with humility and clarity. This is what philosophers call the hard problem of consciousness. How does subjective, qualitative experience, the redness of red, the feeling of joy, the richness of a memory arise from physical matter? How does the water of brain activity become the wine of subjective awareness? While there are intriguing structural similarities between the mathematics of quantum mechanics and the nature of our minds, it is a massive and unproven leap to say that one causes the other. Theories that propose a direct link, such as the idea that consciousness arises from quantum processes within the microtubules of our brain's neurons, remain highly speculative and are not accepted as mainstream science. Quantum computing does not solve the hard problem of consciousness. What it does do is provide us with a powerful new set of tools and metaphors that enrich the inquiry. It forces us to confront the fact that reality, at its most fundamental level, is deeply mysterious and interconnected with the act of observation. The relationship between the quantum world and the conscious mind remains one of science's most profound and compelling open questions, a frontier that invites our continued curiosity, wonder, and rigorous investigation. So, how do we take these abstract, mind-bending ideas and translate them into a practical skill for navigating our daily lives? The answer lies in cultivating what could be called quantum thinking. This is the ability to internalize the principles of the quantum world and use them as a practical toolkit for thriving in our complex, rapidly changing modern world. What does quantum thinking look like in practice? First, it means embracing uncertainty. Instead of fearing ambiguity and rushing to premature conclusions, we can learn to hold the tension of not knowing, recognizing it as a space of pure potential where the best, most creative solutions can emerge. Second, it means thinking in terms of possibilities, not just probabilities. It's the ability to see a situation not as a fixed problem with a single solution, but as a cloud of potential outcomes, and to act in ways that keep positive possibilities in play. Third, it involves recognizing our own role as observers in shaping our reality. This is the understanding that our mindset, our focus, and our expectations are not passive. They actively influence the outcomes we experience in our relationships, our careers, and our personal growth. Quantum thinking is a form of practical mysticism. It's a way of being in the world that is less rigid, more adaptive, and more open to the emergent, unpredictable nature of life. In a world of increasing complexity, the ability to think like a quantum system may be one of the most essential skills we can develop. When we put all of these pieces together, the technological breakthroughs, the philosophical parallels, the shifts in our language and thinking, we can see that we are in the midst of more than just a revolution. We are in an integration wave, a moment where our objective, external science, and our subjective, internal experience are beginning to converge into a new, more holistic paradigm for understanding reality. We see this integration wave reflected in shifts across every field. In education, there is a growing emphasis not just on teaching facts, but on teaching students how to navigate uncertainty and think critically about complex systems. In healthcare, we see the rise of integrative medicine, which treats the patient not as a collection of symptoms, but as a whole interconnected system of mind and body. In governance and leadership, there is a growing recognition that top-down, command and control models are too brittle for our complex world, and a move toward more adaptive, decentralized, and participatory systems. Underpinning all of this is the growth of quantum literacy, not just the technical ability to work with quantum computers, but the broader cultural ability to thrive in a world that we now understand is fundamentally interconnected, uncertain, and participatory. This integration wave is quietly and profoundly reshaping our institutions and our culture, preparing us for a new way of living and being in the quantum age. Now, let us zoom out to the widest possible perspective. What does this all mean in the grand cosmic scheme of things? The quantum revolution can be seen as a pivotal moment in the evolution of our planet, a moment when humanity is consciously learning to participate in the universe's own fundamental creative process. The universe is not a static stage on which life unfolds. From the quantum foam of pure potential, particles and realities flicker in and out of existence. It is an eternal dance between pure, unmanifest potential and the collapse into manifest reality. For billions of years, this dance has been happening on its own. Now, with the advent of quantum computing and a deeper understanding of quantum principles, humanity is learning the steps to this dance. We are building tools that allow us to hold that pure potential in our hands, to shape it, and to consciously choose which possibilities we collapse into reality. From this cosmic perspective, our existence is an expression of the universe's capacity for self-awareness. The consciousness that is looking through your eyes is the same universe that it is looking at. And the technologies we build are not separate from nature. They are an extension of our consciousness, a new way for the universe to explore its own creative potential. Every choice we make, every future we build, is a step in this eternal dance of creation. We began this journey by saying that the pivotal moment of the quantum age has already occurred. The conclusion of our story is to affirm that the quantum future is not a distant event to be awaited. It is a present reality that we are already living within. The transition is now. The transformation is not just happening in cryogenic labs. It is happening in our language, in our art, in our economic strategies, and in our most intimate understandings of ourselves. We are all quantum systems, observing and co-creating a world that is fundamentally uncertain and brimming with possibility. The technologies we build are extensions of our consciousness. They are mirrors that reflect our deepest values and intentions. A hammer can be used to build a house or to tear one down. The immense power of quantum computing is no different. It is a tool, and the ultimate decision about how it will be used rests not in the technology itself, but in us, in our collective wisdom, our foresight, and our compassion. The greatest lesson from this journey into the quantum realm is that our choices matter profoundly. We are not passive spectators of a predetermined future. Moment by moment, we are participating in the collapse of infinite potential into a single shared reality. The ultimate challenge and the ultimate opportunity is to make that participation a conscious, wise, and courageous one. What is one area of your life, be it a personal challenge, a creative project, or a professional problem, where you could apply quantum thinking by embracing uncertainty and holding multiple possibilities open, rather than rushing to a single answer? Share your thoughts in the comments below. Thank you for joining me on this incredible journey. I wish you all the very best of health, happiness, and wisdom as we navigate this remarkable era of change together. And if you found this exploration valuable, please don't forget to like this video and subscribe to the channel for more deep dives into the future that is already here.